Okay, so we should probably move on to the update of what's going on with with Rust. This has been a good 6-month-long process now, a lot longer than we had originally planned. Amidst other things, we had to do DCBOR along the way, which meant we had to go back and rewrite some of the Swift work that we'd done. So I think it was a good not side project, but a good
it's a milestone on the path, even though if it wasn't planned for. Sometimes these things come up and you just have to bite the bullet and take care of them. It does make everything better down the road, you know.
So Wolf, we are recording now, but I'm going to make a separate part of a separate recording. So if you would
reintroduce myself
and introduce yourself and everything.
Yep.
And
you want to show, there's only 2 slides if you want to show the first one, and I might share my screen a little bit as well.
Okay. Where did it go? Second, I don't want to reproduce the problem I did before. Where'd it go? Darn it. Shannon, can you pop up that URL again?
Yeah, let me see if I can get it.
Must have closed the window.
Sure, no problem.
Whoever can find it first can share first.
Actually, well, I can probably do.
Why don't you go ahead and share, Wolf? I'm sorry,
yeah,
I got.
That's okay. Yeah, 1 sec here.
Okay,
my usual environment.
Yep, one moment here, because I'm going to be talking anyway. Okay. So first, I'm going to share this. Okay, you should be seeing my browser.
Yeah.
Right. Yep. So I'm Wolf McNally. I'm the lead researcher for Blockchain Commons, and I'm just going to give a brief update on our progress in porting what we're calling the Gordian ecosystem over to Rust. The primary place we're starting is Swift. That's because I'm an Apple geek from a long time, and I think Swift's a great language. And of course, it directly drops into iOS, and our reference apps like Gordian CTool are on iOS, but the world is much larger than Swift. And so Rust is one of the other platforms we've targeted, software platforms we've targeted, because it's basically pretty much interfaces with everything. So really briefly, I wanted to go over these libraries. At the bottom, or the top of the list, there is DCBOR, which stands for Deterministic Concise Binary Object Representation, or Deterministic CBOR. And this is a variant or profile of CBOR, which we are actually working with the CBOR working group to try to get it closer to an RFC. There's a few details we're working out, but just basically, when working with CBOR, the CBOR spec itself, think of it like binary JSON. So it's more compact than JSON, and it describes certain ways of making things more deterministic. Well, for our higher level needs, although at the bottom list you see a BC envelope. Envelope needs deterministic encoding because it does a lot of things like signatures and encryption and things like that, and it's a hash tree. So you want basically two separate creators of the same envelope with the same starting data to come up with the same envelope, essentially with the same hash, and make that comparable. And so, a very simple example of non-determinism is like if you think about JavaScript, how many ways are there encoding the number 1? Well, you got 1 and 1 point and 1.0 and 1.00. There's an infinite number of ways of encoding the number 1 in JavaScript, and there's things like JavaScript canonicalization things and so on that standardize that, and they're quite complex. CBOR has it a little bit better, but in other ways, it's left certain gaps in terms of, for example, how numerical numbers are encoded. It has a number of different ways of encoding, like the number 1 can be encoded as 1 byte or 2 bytes or 3 bytes, 4 bytes, that is. And so, we wanted to harmonize that with deterministic CBOR. And our approach, I'm not going to get into detail here, but This is one of our 2 reference implementations. The other one is in Swift. The implements are still slightly evolving specification for DCBOR. We have an internet draft, which is like, not an RFC, but it's kind of like on the early path to an RFC for this. But the whole point is, you put certain data in, it should always have, you should always get the same serialization in CBOR. So that's the goal of that. On that is our UR library. This is actually based on a third-party UR library, but because I'm the kind of pedant that I am, I wanted a specific kind of interface on it. So this wraps that third-party, which is just called UR, and that's available. These are for the most part. Well, DCBOR is on crates.io, which is the repository for Rust crates. None of these other ones are yet. The one that BC UR is based on this is called UR. So you can find that there and start using that today. It includes the fountain codes, all those things. But this is kind of our flavor on that, wrapped on that. The next level is, actually there's one I should have put here that's not, it's the crypto layer. BC Crypto Rust, I should have mentioned that. You'll see that in the next slide actually, is kind of our repository for all our cryptographic implementations. And those are usually based on third-party reviewed cryptographic implementations when possible. Not all of them are. But we wanted a way of easily swapping those in and out and have the same kind of interface on all of them. So the BC Crypto is where those live. And then BC Shamir is essentially just the Shamir's secret sharing algorithm. It can split up to 32-byte 128-bit secret into up to 16 shares, and then recombine them if it's given a quorum of shares. And that's all it does. But that's because that's considered to be very core. That's separated out. That's based on our C implementation. And then SSKR is built on top of that. The sharded secret key reconstruction basically not only can break a share up into multiple shares, it can break them up into groups of shares. So you can say I want not just 2 of 3, but 2 of 3 of 2 of 3. So you can have 3 groups. You need a quorum of 2 of those, and then each group you need a quorum of 2. So that enables a number of different secrecy scenarios or backup scenarios that aren't available with just a 1-layer Shamir secret sharing. And then finally, there's envelope. Gordian envelope is a kind of a generic container for hierarchical data. It's built on the idea of a Merkle tree, a hash tree, so that, and then it has a number of different kind of advantages in terms of use holder-based elision and so on. We have other videos up and so on, other talks I've given where it goes into that. But that's kind of the built on all this other infrastructure. The second slide I want to show is just kind of the hierarchy of these right now, the dependency diagram. The blue ones are the libraries I was just referring to. BC Crypto Rust has a lot of dependencies but these are all either very well regarded or sometimes they're security reviewed crates, but they're all pure Rust. Oh, except for currently SecP226K1. There is an alternative I've looked at, which is pure Rust, but this one actually, if you bring this in, it does actually underneath cargo, I guess, compiles the C library and brings in pretty seamlessly. So, but this is used for a lot of our ECDSA algorithms. So, but all these other algorithms are used at higher levels in this. And I also have put like our pseudo random number generators because we primarily use this for fuzz testing and things like that. But because I wanted to unify how we're generating random numbers as well. So, there's the BC Shamir, there's BC SSKR. This is the DCBOR layer, which has kind of minimal dependencies. BC UR Rust, which depends on the third-party UR crate. These are all combined together in what I call BC components. This is higher level components. These tend to like hand back things like arrays of 8-byte integers or 8-bit integers, whereas this actually tends to deal with objects itself and kind of vends higher level objects to other clients. So this is kind of like a high level toolkit. And then BC envelope is built on that and the other layers as well. So the other thing to note about this is I've only begun to review which of these. If you're a Rust programmer, you realize that sometimes if you're building a constrained environment, you want to be able to use the no standard version of libraries. Most of these, if not all of them, have no standard versions. I'm going to be reviewing that very closely as a later phase of the project to make sure that ultimately our whole stack can run in a no standard way. Another thing that so today basically these These are available as separate repositories currently. They're not all up on crates.io. Like I say, DCBOR is, and the UR library is. Of course, all the third-party stuff is. But most of these just you have to put in the same directory and compile together in the same workspace. Currently, when a little bit further down, I will launch them all as actual crates on crates.io. And we'll begin actually semantically numbering them and things like that. The other thing that I will add a layer time is featured gates, so that if you don't need, for example, compression, you'll be able to tell the envelope library, I don't want compression. That will tell BC components that we don't want compression, which will basically mean min-is-oxide, which is the deflay algorithm won't be brought in. But that's for a later phase of the project. So right now, a lot of the functionality is there in envelope, including SSKR. That was just committed today on the master branch. So you can actually see the unit tests. In fact, that's the other thing I'd like to show you, is I'd like to really briefly flip over here to, let's see, to my code here. This is just a unit test of the SSKR library. I'm not going to go to this in a lot of detail. I just want to kind of show you the scenario. This is how SSKR, which is, of course, again, is for backup and recovery, but SSKR only splits 32 byte secrets, or up to 32 byte secrets. Whereas with envelope, crypto envelope, the big advantage is you can split secrets of any size. And so in this case, we have a scenario where Dan has a cryptographic seed, but it's not just a seed. The seed object has metadata. It has name of any length, optional creation date, and a note, which could be of any length. So really, this is an arbitrary length thing. And we want to be able to, for Dan to be able to back up his seed along with all its metadata to say, 3 parties, and then by recovering any 2 shares, be able to recover the entire seed. So, so in this case, we generate a symmetric key for encryption. And again, this is part of the tools that are in the components library, is symmetric encryption, public key encryption, SSKR, all those things. And then we enclose that in an envelope. So we say, okay, put Stan's seed into an envelope. And then we want to encrypt the subject of that envelope, which is the seed object itself, with this content key. And that unwrap, if you know anything about Rust, this basically means you were checking for errors here. And we're assuming there will be none because it's just a unit test. So at this point, we actually have an encrypted envelope. And we have the symmetric key, the content key. So now we're going to define a group. We're going to say this group means 2 of 3 shares. That's there will be 3 shares. The quorum is 2. We're only defining one group in this case, and then we're tying a group spec. The quorum is 1, and then we're giving it the vector of groups. So so we've created a group and a spec. So this can have any number of groups in it that we want. And then we're going to split that using SSKR split, encrypted C envelope split with the spec and the content key, unwrap that. And now we have basically a list of envelopes for however many envelopes here. You see it's a vec of RC, which stands for reference counted envelopes. So each group is the inner vector. The groups of the outer vector. The shares in each group are the inner vector. So now we're going to flatten that. So we just call it flatten. So we have a list of things, and then we're converting this into URs. So we're basically have a map here where we're just saying, just convert this to a UR. And now we have a vector of URs. And this is assume what we're saying in our fake scenario here. We're saying, so we're just going to check one of the things we're going to say. Here's what we expect our envelope to look like. It's an encrypted message with an one assertion, which says this is an SSKR share, and here it is. So we're just basically kind of going to format that envelope and verify that, yep, that's what that envelope contains. So now Dan sends one of these envelopes to each to Alice, Bob, and Carol. That's the symbology I have for that. Those envelopes traversing the internet. Alice never or lost hers, basically. So we're going to say that's unrecovered. So Bob and Carol take their 2 envelopes and they check them out. So they get things like looks like this. They can't recover the message by themselves. So at some future point, Dan retrieves 2 of the 3 envelopes so that he can recover his seed. So these are 2 recovery that he covers, Bob's and Carol's. The clones just because reference counting in Rust. The recovered seed envelope, he basically says SSKR join with the recovered envelopes. And then that's just debugging information. Just make sure you got I should remove that because that's not properly part of the unit test. And then he recovers the seed. So he extracts the subject with the seed. And then he just compares. Here's the original seed. Here's the recovered data. They're all equal. If Bob just tries to use his share by itself to join it, it's an error. And so if I run this unit test, it'll pass because all these unwraps don't throw errors and all the asserts pass. So that's pretty much as simple as it is to do basic SSKR using Rust. And that's concludes my report. I'll take some questions.
Yeah, so Wolf, what's the kind of I mean, you've talked about having, looking at the no standard and other things. What do you think is well, let me back up a step. So we have we obviously this is not reviewed code yet. We consider the first stage of our process is what we call community review. And I would say we're even a little early for community review. So, but we did the Rust version because we had a number of parties that were basically saying, hey, we love your reference code in Swift, but we need to do it on Android. And so we had kind of this trade-off. Do we do it in Kotlin, or do we do it on something that also works on Android, but is a little more rare than pure Kotlin stuff? And we really would like to see some people beginning to play around with this that are, in the Android ecosystem. And then, of course, Rust is kind of the leader right now in security implementations, with most, Signal, even Bitcoin, everybody seems to be moving more toward the Rust ecosystem for things. So then are there people that have some specific needs there that can help us? And then I would ask you, Wolf, what areas are the ones that would be the best for either the Kotlin, Android type people to take a look at now that you're ready for, versus the people that are doing, deeper, more secure cryptographic apps. So what feedback do you need?
Well, obviously, right now, if people, obviously they're not up on crates.io yet, so they're a little bit more of a pain to kind of set up this, but they're basically, you throw all these projects into one directory, open them up in a Visual Code workspace, and you can just build them together and run the unit tests. I have a script I use to just run all the unit tests of all the crates together. But I mean, obviously, for example, I'm showing right now just the hazmat part of the Shamir algorithm. This is basically, as much as possible, a line-for-line conversion of the C code. So it should be pretty easy to review as correct or not. I also basically, on the SSKR level, I wrote a fuzzing algorithm to basically try a huge number of different kinds of groupings and so on, and then make sure there's a quorum that is always recoverable of those. So, but obviously, making sure that this stuff is reviewed. I mean, for example, my understanding is the original author of this code, tried to make sure these are all constant time algorithms. As far as I know, I preserved that, but not being a cryptographic expert, I can't say for sure. This is something for actual cryptographic experts to look at some point. But it's certainly ready for, as you put it, community review, to start kind of poking at it. It's not very well documented yet, but again, it's mostly a direct conversion of the Swift code at the higher levels. And also, as I've been kind of realizing that certain things I'm doing in Rust, could actually make sense in the Swift code, I've been backporting that. So the master branch of these various Swift libraries, I've been committing to that, as well as I realized, oh yeah, that's a good way of doing things that Rust kind of made more natural, and it works in Swift too. So I've been upporting that back to the Swift libraries. So I'm not sure whether I'm answering your question or not, but basically, if you want to start understanding, because there's not much documentation on the Rust version of Envelope yet, there's a lot of documentation on the Swift version at that. But for example, you can look at, for example, say core tests, where you're, just testing various kinds of tiny envelopes, making sure they're various things like their digests at the various parts of the tree are invariant and so on. These have all been tested to be identical to the Swift version. But it should be, there's a lot of things that the Swift version does that this doesn't do currently, like diffing and mermaid output and stuff like that. But I think most of the essentials are there. I've still got a couple little things to work on before I really start documenting. But yeah, I mean, by the end of this week, there'll be, I think I should have it on crates.io and ready to really kind of start, poking it more seriously. But, will they be ready to ship a product with? Probably a little bit longer. But part of that is also, who's going to join us, poke at this and say, oh yeah, this is, I tried to do this in my app and it was very awkward using the API. Can we improve the API? And then kind of go back and forth on that. So of course, because I'm using the lower level stuff at my higher level stuff in envelope, I am getting a chance to kind of say, oh, that's awkward, and then fixing it at the lower levels.
So another, obviously Wolf is using the Xcode development environment for running all of this. In theory,
For Swift, I'm using VS Code and for the Rust stuff.
Right. But I mean, but you're running on a Mac environment, I should say.
Yes, I'm running on a Mac.
And we have run into things in the past where running on a 32 bit processor on Linux or whatever caused a problem. So we are looking for people to bring this to other environments and just make sure that you can run the scripts that test all the dependencies. It's possible that some of our Mac is notorious where some of the shell scripts and things of that nature are just slightly different than what is shipped with Linux. And
of course, for Rust, I'm only using Cargo. I'm not writing any custom build scripts or anything like that. So if Cargo works, it should work. But the proof of that pudding is in somebody else doing it too.
Right. And then of course, how we are not idiomatic Android engineers. So somebody basically taking a look at this and going, okay, this is, what is necessary to include this in an Android build that we're missing, or, oh, it'd be easier if you did X. So I kind of consider this to be the pre-community review stage at this point. But we really want to get to community review by the end of the month. And that will be a formally labeled release. Everything will be in Cargo that we have, but is still should not be considered ready for production. We're trying to be more careful about this.
Well, certainly we're not calling anything 1.0. Everything's going to be 0.1.0 for now.
Some of the things that we really want to do, the most sensitive parts of the code are that hazmat C and a couple of other parts in the Shamir and SSKR. So, we either need to commission somebody like Radically Open Software or somebody of that nature to do a formal security review of the more important little parts. And generally what we do is we pass around the hat. So all the parties who think that they're going to be wanting to ship those, this year, we'd love people to, throw some money in the hat to try to commission a formal, proper security review by an independent third party of these. When that happens, then we will, and hopefully, some people are beginning to do some proof of concepts or prototypes of various forms. We'll be ready to declare a version to be, a 1.0 release. I don't think that'll happen before the end of the summer being, and September, it might be after that, depending on how much support we get from the community on priorities for this. What am I missing anything, Shannon, Wolf?
Sounds right to me.
So we are going to begin to, so we have a code base in Swift that is called seed tool for Gordian seed tool. It's on the App Store. We would really love to see somebody tackle the the rough equivalent of that as a reference Android app. We're not quite prepared to do that right now. I think our resources are, we could and we will if we need to, but I'd love to see that parallel. In the meantime, we're going to be returning to Swift to start building the rest of the CSR stack. So so you can actually have a real app that you can send shares to, request, please please store this share for me. Only return it if some mutually agreed upon authentication is acceptable, which can be none. That's kind of what happens today, but we want to be able to offer those types of things. So we're hoping to have some at least working prototypes of that also up and running over the summer. So obviously, if we can do it just between the reference apps, that's not going to demonstrate what we really want. This is where Andy, I would love to see if we can, select some subset of what you're doing and be able to demonstrate that a QR request for please, save this seed works with your app as well. Even if you aren't necessarily doing all the Gordian stuff that is, a full support for envelope. I know that, we've been talking with Foundation Devices. We had hoped that Proxy was going, they had said here in these meetings publicly that they were working on it. That's why they did the SSKR. But being that they were just acquired by the Hour Ring company, they're in the midst of that merger. So I don't know what their plans are. Anybody else working specifically on Shamir or SSKR or CSR things in the next couple of quarters?